Hello everyone, today I'm going to show you how to draw hybridization without using orbital diagram at all. To start, we know that hybridization happens when s orbital and p orbital mix together to make hybrid orbital, right? Yes, the s and p orbital combine into a hybrid orbital. Normally, we have to excite the atom first to make the energy levels equal, right? Okay, but we don't need to waste time to drawing all of that. Okay, we have just two simple rules here. First, we have hybrid orbital, and second, we have pure p orbital. When we draw a hybrid orbital, it has one small side and one big side, like this. For the p orbital, it look like this. It looks like a number shape on the Y, Z, H. We see this all the time. The trick is that we must know how to draw basic bond first. We need to know the shape of that molecule. Okay, let's look at hybrid orbital first. In this clip, we will only talk about sp, sp2, and sp3. Right now, we need to know what shapes sp2, sp3 are. This matches covalent molecular shapes. For sp, it is linear. This means it has two atoms attached. For sp2, it is trigonal planar, and sp3 is tetrahedral. The trigonal planar shape has three atoms attached, forming a triangle. For the tetrahedral shape, it has four atoms attached. It looks like a four-faced pyramid as we know. Now, how do we spot them? For hybrid orbital, there are two things to look for in a molecule: sigma bond and lone pairs. What is sigma bond? It is a bond that hits head to head. It connects directly like this. The easy way to spot it is that it's single bond. Just look for single bond. Got it? Okay. For lone pairs, let's look at carbon monoxide. The lone pair are this dot here. Yes, these two things, sigma bonds and lone pair, we must draw them as hybrid orbital. Okay. And now let's look at pure p orbital. Pure p orbital are only for pi bonds. To find pi bond, look at double bond and triple bond, or both. Okay, clear? Lone pair and sigma bonds use the hybrid orbital shape. Pi bond use the dumbbell shape of a pure orbital. Okay, now let's try an example. We will draw carbon dioxide first. We need to draw carbon dioxide, find its shape, and count how many lone pair sigma bond and pi bond it has. Okay, for the drawing, we know carbon dioxide is linear, right? We must draw it like this. For the lone pair, the way to think about it is oxygen follows the octet rule. We must make sure this oxygen has 8 electrons, right? Right now, the oxygen on the right has 4 electrons. So we need 4 more. We will add 2 pair of lone pair, right? The left side is the same. Got it? Now look at carbon. A carbon has 8 electrons, which is full. Okay, let's check. Like I say, we need to know the number of sigma bonds. Now we know the shape. Let's count the lone pair sigma bond and pi bond in this molecule. We have a total of 4 lone pair, right? 4 lone pair for sigma bond, which are the single bond we have 2. And for pi bonds, we count from the double bonds. So we have 2 pi bond. Okay. Sorry, we have 2 double bonds. And like I said, these two will use hybrid orbital, and this one will use a PLP orbital, which is the dumbbell shape. Okay, let's draw its carbon is in the center. It has hybrid orbital for the lone pair and sigma bond. So the hybrid orbitals go down to touch oxygen for oxygen. It also uses hybrid orbital because it has a single bond too. And they connect, right? Okay, now for oxygen, the hybrid orbital is used for the single bond, which is the sigma bond, but it also have lone pair in hybrid orbitals on both oxygen atoms. So those are the lone pair. Got it? Okay. Okay, clear. Next, let's look at the double bonds. Double bond means pi bond, right? Pi bonds are the double bonds and up. It could be triple bonds or more. Okay. Now for the pi bonds, we have two, right? Here and here. To connect this pi bond, carbon must have two dumbbells. Let's put them on the x-axis and y-axis. Now the oxygen atom must also have pi bond to match the carbon on both sides. This means each oxygen has one pi bond orbital. Okay, this let them overlap on the x-axis and y-axis. Okay, so they connect on both axes, making pi bond on both sides. Okay, we are done with carbon dioxide. Clear. Let's look at the next one. Okay, next is cyanide, the cyanide molecule. It has carbon in center, a triple bond to nitrogen, and single bond to hydrogen, right? The shape is linear, so it is sp, right? Okay, for sp, let's look at it. The shape is linear. Next, let's count the lone pair. Pi bond and sigma bond, let's check. Let's start with carbon first. Are the lone pair complete? Use the octet rule to see if carbon has a electron. Let's count 1, 2, 3, 4, 5, 6, 7, 8. Okay, carbon had no lone pair. Now look at nitrogen. 1, 2, 3, 4, 5, 6. This means nitrogen has 6 electrons, right? Now it needs 2 more. So we just add 1 pair of electron lone pair, right? Okay, and for hydrogen it has 1 valence electron. Hydrogen only needs 2 electrons to be fulfilled. So we need add 1 more electron. Now hydrogen has 2 electrons around it, so it is stable. Okay, now we know the lone pair and pi bond. Let's look at the sigma bond first. We have 1 lone pair on nitrogen. For sigma bond, those are single bonds, right? We have to write. For pi bond, we count from second bond up. So in the triple bond, we have 2 pi bonds. Okay, clear. Now let's draw the hybridization. Like I say, sigma bond and lone pair mean the hybrid orbital shape, right? And pi bond mean the dumbbell shape. Okay, let's look at carbon. Carbon has 2 pi electron and 2 sigma bond. So it has 2 hybrid orbitals for the sigma bond and 2 pi electron, which mean 2 dumbbells. Sorry if my drawing is not beautiful. Please forgive me. Let me try again. Okay, for carbon, look at what is around it. It has 2 single bonds, meaning 2 hybrid orbital, and 2 pure p orbital, meaning 2 dumbbell. Right? Okay. Then look at hydrogen. We can just bring in hydrogen into bond. Okay. Now look at nitrogen. What is around nitrogen? It has a lone pair, 1 single bond, and 2 pi bond. Okay. For nitrogen, let's start with the lone pair. Lone pair are hybrid orbital, right? So it means lone pair on the right. Then it has a single bond, which is another hybrid orbital. Now it has 2 pi bonds, just like carbon. So it also has 2 dumbbells. Okay, now we can connect the bond. See, with this method, we don't have to draw orbital to mix or move electron at all. We just need to know that a sigma bond or lone pair is hybrid orbital. A pi bond is dumbbell shape with this pure p orbital for the x, y, and z axis. We can choose them ourselves. Don't overthink it. Okay. Now cyanide is done. Okay. Now the last one for today is ammonia. First, we need to know its shape. Its shape. For this one, the shape is tetrahedral, right? We can draw it like this. Right? Now it's easy. Next step to we need to know how many lone pair pi bond and sigma bond it has. Okay, a tetrahedral shape means sp3, right? The lone pair to the lone pairs total 1 because it's on nitrogen. There are no pi bonds, so that's 0. How many sigma bonds? 2, 3. Single bonds. So there are 3, 1. Okay, let's draw it. Start with nitrogen lone pair and sigma bond are hybrid orbital. So they take this shape, right? Next for hydrogen, we just bring them to bond. Done. That's alright. Finally, here is an exercise for you. I will give you the shape of this molecule right here, the structure. Okay, these two. I will show you the answer for this one and you can try the other one yourself. Okay, for this one, I will draw it in 3D dimensions. Okay, we need to know the structure, but here we cannot just look at one central atom because there are many. We have a, we have carbon and nitrogen, so we will do it atom by atom. Okay. Now it's organic compound. Every corner means a carbon atom, right? Let's look at each atom. Look at nitrogen first. For this nitrogen, it connects to carbon with a single bond and to hydrogen with a single bond too. This sigma bond, which means hybrid orbitals. And it has a lone pair on nitrogen, which also hybrid orbital too. The sigma bond on nitrogen have 3 lines and there is one lone pair. So we draw nitrogen like this. Connect to hydrogen here and connect to carbon here. Okay, and nitrogen also has lone pair, right? That another one. Now nitrogen is done. Let me draw it better. Okay, now okay, now for this carbon. On this side, these carbons had plane of symmetry, right? So we can think they are the same. we can draw one first, then draw the other. This carbon has single bonds into place, like, right? Okay, single bond into place, and it has a pi bond in one place. The single bond I drew is the hybrid orbital connecting to nitrogen, right? Then it has another single bond to another carbon. And a pi bond, right? The pi bond is a dumbbell and I will put it on y-axis. Okay, get it? Okay, this carbon is done. Let's look at the last carbon at the corner. This carbon has single bond to this carbon. A single bond to carbon and is one pi bond, okay? Then we draw the carbon with the single bond connecting right here. And don't forget the pi bond on this carbon too, right? So it will be dumbbell right here. For this carbon we draw is exactly like the carbon on top. And don't forget these two bottom carbons connect with a single bond which is a sigma bond, so it's used a hybrid orbital to connect them. Okay, now we put the electron in the pi bond, which is the double bond happens when these two p orbital connect. Okay, this structure is finished. The main thing is to understand the rule. Look at what is around each atom. If it has lone pair and single bond, it's used a hybrid orbital, right? If it is pi bond from double bond and up above, double bond, triple bond, or whatever. But it must be a double bond and up. It will be a dumbbell shape, right? Okay, got it now. I will let you do this one, okay? Go back and try this one. Okay, that's all for today. Thank you for watching.